Dear students, let's proceed with our lectures on consideration of processes at incidence of electromagnetic wave with rather high frequency, which length of wave is comparable with dimensions of the considered circuits. And in such a case, we will consider these circuits as circuit with distributed parameters. And we are considering now switching DC voltage U0 on a cascade connection of two lossless lines, first with impedance ρ1, second with impedance ρ2. And in such incidents, the so-called incident wave is applied to first line, and when this line will reach junction between first and second line, the so-called refracted waves will appear in first line, and the so-called the so-called reflected waves will alongside with incident waves will appear in the first line, and the so-called refracted waves will appear in the second part of the wave of this line. And in previous lecture it was shown that knowing impedances of first and second line, we can write down equation which connect reflected and incident wave currents and voltages, and refracted voltages and currents with level of incident wave. It is done by when we equate levels of voltages and currents and junction of these two lines. So when we've got such expression, the so-called reflection coefficient, which is designated as Q, for current it's I and for voltage it's U, and the so-called refraction coefficient, you see it's this Q, and refraction coefficient is designated as Pi and Pu for corresponding for currents and voltage, and they can be expressed as follows. It is Qu equal to ρ2 minus ρ1 over ρ2 plus ρ1, Qi. This refraction coefficient equal to here ρ1 minus ρ2 over ρ1 plus ρ2, and refraction coefficient Pu equal to 2R2 over R1 plus R2, and Pi equal to 2 ρ1 over R1 plus R2. You see, here we can see, from this expression, we can see that reflected current voltage and refracted current and voltage differ from incident voltages and currents only by these coefficients. So their waveforms will be the same for linear lines, for linear lines, one of the refracted wave, either current or voltage, will have the same sign as incident wave, and the other current and voltage will have an opposite side. We can see it from here. You see here Qu and Qi will have different signs, you see, because here we have ρ2 minus ρ1, and here we have ρ1 minus ρ2. Independence of correlation between ρ1 and ρ2, we will have either Qu greater than 0, and then Qi will be less than 0, or vice versa. Refracted wave and voltages, we can see that they will have the same signs. See, it is all a time it is positive signs. Let's consider a case when we have the so-called cable line and open overhead line CL and OL. For instance, when we have overhead transmission lines, power transmission line, and in the city, such overhead power transmission lines should be connected to cable lines, because in the cities we as a rule have not this overhead high voltage line. Let's consider that impedance of the cable line equal to ρ1, impedance overhead or O line equal to ρ2, and speed of propagation of electromagnetic wave in the first in the cable lines equal to V1, and in the overhead lines equal to V2. Let's consider that cable line is connected to the source which Z1, which impedance is much less than impedance of ρ1. It tends to 0. Let's consider that open circuit line that overhead lines is open at the end of this line. So Z2 impedance, which is connected to the end of overhead lines, will be equal to just to infinity. Length of the cable lines will be designated, will be equal to L1. Length of the overhead line will be equal to L2. We can write down that Q1 equal to, as it was shown, equal to ρ2 minus ρ1 over ρ2 plus ρ1, and Qi equal to ρ1 minus ρ2 over ρ1 plus ρ2. And incident wave will propagate through first this cable line with velocity v1 at length L1. So at the moment T1 equal to L1 over V1, this wave will reach junction between these cable lines and this overhead line. And values of and from this moment in the cable line reflected wave alongside with incident wave will appear, and in overhead line refracted waves will appear from this moment. And let's designate that ρ1 less than ρ2, and therefore sign of the reflected wave of the reflected wave of voltage will coincides with the sign of the incident wave, as ρ1 is less than ρ2. So numerator will be greater than 0, so Q1 will be positive, so sign will be the same as of incident wave. And Qi sign will be less than 0, because ρ1 is less than 0. So sign of current reflected wave will be opposite to the sign of the incident wave. Therefore, voltage will after passing after this junction between these two waves will be reached, reflected voltage wave will have the same sign, so resulting voltage will be greater than incident wave, and current, as I reflected, is less than 0, so current will be less than current of the incident wave. Then let's consider at junction we will have the same level of voltages in cable lines and in overhead lines. So refracted wave which propagate in the overhead in the overhead line will be greater than incident wave in the cable line. The same refers to current. Current here will be less than incident current. In the next lecture, I will finish this part of consideration of propagation of waves in a combined line consisted from two parts of line with different own impedances and with different speed of propagation in these both lines. Bye bye for now.